Next one is the unilateral Laplace domain for a general polynomial, which you're going to be a little bit shocked what it's going to turn into because we finally get to use our gamma function over here to prove it. Now, this gamma function is something that I talk about but never use until this stage over here. And I'm just going to showcase it because the actual proof of it is basically a lot of introversion and a lot of integrals. We're not doing that. So we're just going to assume this is true. Now, we plug this into this place over here to get this format. And with that format, what you can do is do a U sub, a simple U sub, to get it into a better format until you get the same over here as this over here. Basically, then you realize this is Ni, and basically that's why you get that in the end of the day. Simple as that. It's nothing special. And then we move on to our exponential function over here. The exponential function, again, you're just putting into the Laplace domain over here. We're doing exponential to the Laplace, and then you're just doing that integral over here. And you see that the limit of this just goes to 0 because we're assuming basically this shows us a is constant. So you're going to have something like this, and you're going to realize either way, if it goes this way, or something like this way to this way, you're going to go to 0. I think it's going to be more likely this one. But anyways, basically you get 0 as you go to infinity because a is just a constant in the end of the day. Over here next you move on to the sine in the Laplace domain. And this one is a little bit more interesting because you have to use Euler and Euler and other stuff. But once you realize that you can slowly just solve this out and you get to here and basically what you realize is that this will go to 0, this will go to 0, finally getting this. And after that, it's just simple algebraic thing to get the final result. Yeah, it's a lot of this is just plugging into the formula. Why we're doing this is going to be later on when we solve ODEs with it. Anyways, the cosine is similar to, I just put it over here. The cosine over here, as you can see, is, I shortcut it because it's kind of clear. When we go to Fourier's is more interesting, which I don't think I have time here, so we'll talk about that next time.